Hello, everyone, and welcome back to the Cloud and Streaming stage. I hope you had a nice lunch and feel rested and full of energy and ready to hear more exciting information. The next talk is by Ricardo Sueiras, who is the principal advocate for open source at AWS. And he's going to be talking to us about how to get started with data pipelines using Apache Airflow. I'm looking forward to this, Ricardo. So I will hand straight over to you, and you can take us away.
Great. Thank you very much for the introduction. And hello, everyone, to Big Data 2022. My name is Ricardo Sueiras. I am a developer advocate, and I have been working with open source technologies for over 20 years. And one of the things that I really love about working with open source is the fact that open source builders like to start with a problem. And it's sometimes called the itch they try and scratch. And so in this session, I want to share about one particular itch that led a group of developers in a company to tackle a very important problem for that business, and has led to them creating one of the most popular and best loved open source projects. So let's see if this works. Yes, good stuff. So if you look back at your own organization and how you need to get data from the source of where it's created into the hands of the people that can make use of that data in order to help your customers create better products, create better experiences, then there's a number of different steps you've got to take. You know, we need to collect the data, we need to store it wherever it resides, we might even need to centralize it. And this data typically is spread out all over the place. We might need to do things like clean that data, filter it based on our needs. We might need to combine that data and then finally store that somewhere like in a data lake or a data warehouse. And we need to do this in a way that is secure, so that only those people that have access to that data can have access to that data, okay, across all those different steps. Now, it's very common, and even today, for many organizations to manage those discrete steps separately. And then they use tools such as cron to schedule the automation of those. Now, that's fine. But one of the challenges that as you start to scale the use of business within your business, it becomes much harder to manage all those different steps and tasks in that data pipeline to make sure that you have consistency and reliability. So what was really needed was a way to orchestrate those different steps, in your data pipeline. And what emerged in the kind of early 2010s was commercial software that would allow you to start to do that. But one company, Airbnb, around 2014, decided to create and then open source a tool that they were using to solve a similar problem. And Apache Airflow was born as a workflow management and orchestration tool that helps you create and manage those complex workflows. It began, I think, as a sort of project in 2019. Sorry, it was open source in 2014 and then became a top level project in 2019. So what I want you all to take away from this talk really is to have a better understanding of the key concepts and terms and architecture of Apache Airflow and how you can use it to create your own data pipelines and solve similar problems for your business. Now, one of the, I mentioned the different tasks that you typically have when creating your data pipelines. The grouping of those tasks is what we call a workflow. And within Apache Airflow, workflows are defined as directed acyclic graphs, or DAGs. And these DAGs really are just that collection of tasks, that help you achieve your desired data pipeline. Now, in Apache Airflow, our workflow, or DAG, I'm going to use those words interchangeably, is represented in Python code. And we have, within this file, we have a number of characteristics that define our workflow. Each workflow has a unique identifier, which we call the DAG ID, and you can see that in the bottom right. And we're going to show more of what this looks like when we actually come out of the slides and actually go on and do a hands-on demo. Now, a unit of kind of work within that workflow is called a task. And again, this is represented by Python code. And like our DAG, each task has a unique identifier, and we call that the task ID. Now, in order for tasks to be able to complete something useful, something for data engineers and for our data pipeline, we use this concept of operators. And operators determine what work gets executed. And you can think of operators really as templates that you provide some information, but they do all the heavy lifting of interacting with all the different systems that you would have as part of your data pipeline. And we're going to go into details when we go into the hands-on demo, and you'll get to see what they look like. Now, there are different types of operators. Some are used to interact with systems. Some are used to wait and sense for information to happen. Some are used to help make it easier to interact with downstream systems, for example, how to connect to it or how to authenticate with it. So these all are concepts within Apache Airflow that you will become very familiar with as you start using it. Now, at the heart of Apache Airflow are operators, and this is what makes it really easy for your data engineers to interact with all these different systems that are a part of your data pipeline. So this is just a small list of some of the operators, and if you're watching this, you will probably find the systems you're using has an operator. Now, one of the advantages being open source is that you can create your own operators as well. And this is the pattern I see many customers doing, and where they've got their own systems, they create operators to make it easier for their internal data engineers to interact with those systems. So you can use these operators, or you can create your own. And the community really has been evolving and developing and innovating these operators over the last 5 years. So a collection, just to summarize, a collection of tasks is what makes up a workflow. And as I mentioned, these workflows are called DAGs. Now, each task represents a node in the workflow graph. And you can see in the diagram here represented by arrows. So each task has a relationship and a dependency with the other nodes in the graph. And this is where that term directed acyclic graph comes from. And it describes the relationship between each of those tasks. Now, one of the key things to take away from this is that these are directed acyclic graphs, which means that they go in one direction. They're not circular, they don't come back. And that's something that you need to get your head around. Now, within your workflow, your DAG, you determine the relationship by either one of two ways. You can use the greater than and less than operands, or you can use the set upstream and set downstream methods of these objects. And that allows you then to define the relationship between those nodes and how your workflow will get executed. So that's a very quick overview of some of the fundamental primitives of Apache Airflow. But before we can actually now run these workflows, we need to actually understand how to deploy them. Because so far, what you've learned is that a workflow is a Python file. So we have a special folder within Apache Airflow called the DAGs directory. And Apache Airflow will read the contents of this directory, and then it will use that to determine what workflows to run. It will understand and break down within your workflows which tasks need to run. And because it's just Python, if you have any imports, for example, you need to use some additional Python libraries, it will also understand what Python libraries you need to import. So now we've got our workflows within Apache Airflow. What next? How do we actually get these scheduled and executed efficiently? So this is part of the Apache Airflow architecture, which is called the scheduler. And the scheduler understands within that workflow the specific tasks that need to be executed. And so the scheduler will actually go through and parse the workflow and then understand what needs to be executed. And then the execution is done with one of two ways. If you're running what's called a local executor, so typically in a developer environment, the executor will spawn a thread and that will actually execute the task. And it will be linear, sequential rather. However, typically when you're running this in your own environment, you'll run this on a more robust system, And the executor will typically spin up a worker node, and a worker node will actually run that task. Now, a key thing to take away here is that each task may be running on its own worker. So there's no concept of state. We'll come back to how Airflow manages state later on, but you have to treat all your tasks as stateless. So one of the things I see some people try and do, for example, is create a task that writes some stuff to /temp and then have another task that tries to pick up the data from /temp. And obviously they may be running on different systems and servers, so that data won't reside. So you have to treat these things as stateless. Now, once the executor knows which tasks to run, we then need to understand how Apache Airflow then knows when to run that. And this is where the scheduler within Apache Airflow allows you to use a cron tab-like syntax to schedule when you run your workflows. And we can see there in the bottom left that we can schedule interval as you typically would do any cron tab. And we define that in the properties of our DAG, which you can see there in orange. Now, in this example, I specified schedule interval equals none, which means I don't want this to run on a schedule. I want to run this on demand. If I changed it to the syntax that's on the bottom left, I would run either every 10 minutes, 2 hours, etc. Now, for some customers, running using or trying to define their workflows in a cron syntax wasn't flexible enough. So in 2.3 of Apache Airflow, a new class was introduced called timetables. And this allows you to define a timetable property that allows you to specify your own unique timetable. And a good example, as we're currently watching the World Cup, is imagine you were FIFA and you wanted to create a timetable around an event. You could create that event timetable, and then you could schedule your workflows using that construct. Now, one of the things that I see many people struggle to understand when they're scheduling workflows is actually they kick off a workflow and suddenly they see Apache Airflow kicking off lots of tasks and running lots of activities, and they don't expect that. And the reason for that is that we have a concept in Apache Airflow within the property of the DAG called start date. And start date is the time when this workflow will begin. And so if I decide that yesterday is my start date and I have a workflow that is scheduled for every hour, if I kick off that workflow, it's going to kick off 24 tasks because the start date is yesterday. And if it was a week, it would do that times 7 days. So the idea is the start in date will actually kick off your workflows from the moment of that date to where you currently are before it starts catching up. And we can disable that feature if we want by disabling catch up. So here we've got it set to true, but if we can turn that to off by setting catch up equals false, and then when we enable our workflow, it will only start from the point of now. Now, why this is important and useful is that this can be a very powerful capability of Apache Airflow if you want to do backfills. If you want, for example, to rerun all your data pipelines from, let's say, when you started your application or data because you changed an algorithm or you changed some data formula. You could do this and let Apache Airflow do this all in the background with you having to not worry about anything, and Apache Airflow scheduling all the tasks to do that. So it's a very powerful capability of Apache Airflow that you need to understand how it works to use. Now, as Apache Airflow is executing tasks, they're running, some are working, some are failing. There's one step to the next step. This generates a lot of metadata, and that metadata is stored in the metadata database, which is easy for me to say. And this is used to store all the information around all your workflows and tasks. It's also, however, used to store state between tasks. Now, you have to be very, very careful because it's not optimized to store large amounts of data, but it typically is used to provide key information, maybe a record key or something, from as one task finishes to the next. And in the demo I'm going to do, I show this in action. And finally, we have the Apache Airflow UI, which allows you actually to understand how to what your workflows look like, to interact with them, to see how they've run, to get information, the logs, and also to monitor trends of your workflows to see and maintain that they're optimized. So this is a very quick introduction into some of the concepts and the architecture of Apache Airflow, but I like to show people this in action. So I'm going to come out of presentation mode now. Let's have a look if we can do this. And we're actually going to go in now and do some actual work in Apache Airflow. Now, everything I'm going to show you is available on a GitHub repo, which I'm going to share the link at the end of the presentation. So don't worry, you can get the slides and the presentation at the very end of this deck. I'll share the link. But what we're going to do is we're going to go into Visual Studio, and we're going to use an open source project that AWS open sourced a while ago that makes it really easy to run Apache Airflow in your local environment. So if I go to if I go to Visual Studio, I can actually see this running here. And all I have done is run a command within this folder called moi local runner space start. And to save some time, I've actually already run it, and I can show it running by going into here, and you can see that this is running. No, that's running there. You can see I'm running on my local host, and I've logged in, and I can see that I'm now in the Apache Airflow UI. Now, at the moment, the Apache Airflow UI doesn't look very interesting because I've got no workflows, but we'll come to that in a second. But we can see we've got an area here where we'll display our workflows. We have some menu options. The key ones for this demo are going to be the admin screen, where we are going to define variables, configurations, and connections. Connections are useful because it allows you to simplify how you connect to other systems, and therefore make it easier for your data engineers to not have to worry about the credentials. They just need to worry about the ID. Configurations allow you to configure the various operators, and variables allow you to create variables within your workflow so you don't hard code them. And we'll see some examples of that now. But let's actually now go to a very simple hello world workflow so you can actually see what one of these things looks like and how we deploy it. So let's make the screen bigger. So we can see that this is just a Python file, and we begin by importing the DAG object from Airflow and a couple of other classes from Apache Airflow. Now, we're going to use the bash operator. And remember, bash operators within Airflow are templates that allow you to make it easier to operate and interact with systems without you having to have deep knowledge of those systems. So we'll see more of these about what the bash operator looks like in a second. We define some default arguments, and I've just used some basic ones here, but I've got things such as the owner and the email address, but there's a lot of parameters you can define, which are not important for this demo. We then give it a name. So this DAG ID, we've given it my first demo. And as you remember, each workflow has to have a unique ID, a name. Then we specify the properties of this workflow. So we pass in the name, we pass in the default arguments, we give it a description. We're not going to schedule this one, so we've set this to none. We specified the start date two days ago, but again, that's not important because we specified catch up equals false, and then we can specify some tags. So we're now ready for our workflow. I've created some variables. So event name, session, and speaker. If I was using the variables within Apache Airflow, I would define them in the actual UI, and then I would use another class within Airflow to actually then get these as key. So in this example, I'm hard coding my workflow, but to make it a more reusable workflow, I would remove this and change it for what's commented out. Now let's look at the actual operators themselves. We can see the bash operator takes one parameter, which is the bash command. So all I have to do here is actually specify the bash command I want to run. And I'm doing this 3 times to basically display these different variables. So it's a very simple demo. And then at the very end, I'm defining the relationship between those tasks. So I want the display a name first, followed by the session, and then followed by the speaker. So that's our very simple hello world task. And now what I'm going to do is I'm going to copy this. Oop, no, I don't want to do that. My mouse is right, copy. And all I'm going to do is literally copy it into the DAGs folder. So remember, the DAGs folder is the folder that Apache Airflow is listening for, and it's going to pick up the workflow. So now if I go back to the UI and refresh it, we can now see we have our first workflow. Now, at the moment, when a workflow is deployed, it is disabled or unpaused by default. I can enable it by unpausing, and we can now see it's gone blue. If I open up the workflow, we can actually see that what it looks like. We can see it's 3 tasks. We can actually view the code of that task, and it should look exactly like the code we had in VS Code. We can see there's a number of other things we can do with our workflow. We can change the view from tree view to graph view, and typically you will change the view. This view is very useful to see for seeing the historical run of all your workflows. Now, if I look at the graph view, this actually shows me a much more graphical representation of the workflow. Now, you can see that at the moment there's a border color around each task, and these are representative of one of these statuses. And as we run the workflows, you'll see the color change. We'll see light green, dark green when it's running, when it's finished. We should hopefully see some red. I've got some failures to show you how you interact with failures in Apache Airflow. And at the moment, it's white, which is no status at all. So let's start this workflow. We're going to click on trigger. You can provide parameters if you want to, which is great if you want to create parameterized workflows. But in this instance, we're just doing a very simple hello world. I'm going to click on trigger, and we're going to see now the status of this workflow. You can see this one's dark green. It's running. We didn't see it light green. It was too quick. But we can now actually go into one of these tasks, and we can see we get information about this task. And all this information is stored in the meta database. But what I really want to see is actually, did it run okay? So we can look at the log, and we're now looking at the bash output at the bottom here. We can see running command echo big data Europe 2022. Okay. If I go to the tree view, we can now see that although the UI is a bit weird, I have to, oops. All the way over here, we can see that we've got dark green. And as we run more of these, you'll see a historical set of blocks with the different colors to show you the status of these. So that's a very, very simple workflow. Let's now look at a more complex example. So let's go back to the demo. Let's go back to the presentation. So imagine we want to get some data from one of our data repositories. So in this example, I'm going to use the movie data set. It's 3 different data sets. And what I want to do is I want to get the data. I want to split the data. I want to clean the data, then merge the data. And then I want to store this in my data warehouse. Okay, so typically these might be the steps that I want to use. We're going to use a number of different operators. I'm going to very quickly highlight these. We're going to use a Python operator, which allows you to run Python code. We're going to use an S3 sensor operator, which allows us to wait and to see if there's a file in an S3 bucket before we proceed to the next step. We're going to use AWS Athena operators because we're going to use Athena to do a lot of the data manipulation, importing, cleaning, merging. Then we're going to join the data. We're then going to use another Python script and a Python operator to actually clean up. In this instance, what we're going to do is we're just going to remove the letter E from all the movies just to show something working. And then finally, we're going to use the Redshift operator because we want to then take this data and put this in our data warehouse. So this is one of a typical use case you might see. And if I look at back onto my code, imagine that you are currently, the way you're currently doing this today is you have a bunch of scripts that might look similar to this, that download your source files and then copy these into S3 buckets, and then you have a clean script that basically goes through all those files and then removes the letter E. And you're doing this today by running cron tabs. So let's look at actually how and what it would look like to automate this. So I've already got the workflow. Oops, let's make sure I can. Okay, that's better. Okay, so yeah, so we can see now that this is the workflow for the more kind of a real life example. So here it looks again similar to the other Apache Airflow workflow, but now we've got more operators. We've got the Python operator, the Athena operator, the S3 key sensor, and the Redshift operator. So again, these are just imported as part of what's called a provider package. Now, Apache Airflow splits out the different provider packages, so it's just using a pip install to install these. And so whichever systems you want to interact with will have its own package provider. So you need to know what they are and install those via pip. We're then installing some other Python libraries that we're going to use as part of this, which again are to do the cleanup and download script. We then provide it with a DAG ID. Now this time, rather than giving it a name, all I'm doing is telling Apache Airflow I want to use the name of the file name as the DAG ID. Now, the next thing we're going to do is we're going to create some variables. Now here you can see that I'm using variable.get. So Apache Airflow is expecting me to have these variables, and at the moment I don't. If I go to variables at the moment, there is nothing here. So what I'm going to do is I'm going to choose file, and I'm going to try and find it. This is going to be here we go, movie lens. And I'm going to import these, and you can see now I've actually got some variables now within Apache Airflow which my workflows can actually use. So let's go back to here. And so these all correspond to a variable within my workflow. So I can rerun this many different times with different values as I've not hard coded them. Now the Athena, if I actually now go down to the actual operators themselves and look at these operators, let's look at the Python operator first. So the Python operator, it takes one parameter, which is a Python callable. And here, what we do within Apache Airflow, we define a standard function. So here, for example, cleanup, S3 to Redshift, or download. And we specify the code we want to run, the Python code. So here, in this instance, I've just taken the Python code we were running before via cron and just created a function from it. And I can now put it within my Python operator, and it will run as a task. So that's the Python. The Athena operator allows us to interact with Amazon Athena. And here, we just need to specify some additional parameters. So the query we want to run, the database we want to run it, and then the output of that query. Now, if I go further up, we can see that I've defined the queries here as, again, variables. Now, typically, I would put these in a resource file that we would import. But for ease of demonstration, I've just put them in here. But we can see these are the standard Athena's queries we want to run. I don't have to know or have a deep knowledge of understanding how to interact with Athena. I just need my query, the database I want to interact with, and I'm good to go. And then finally, we've got the Redshift operator. And here, once we've actually done our massaging and cleaning our data, we want to put our data in our data warehouse. And so here, rather than have to know and create code to upload that, all I specify are the key parameters that it wants to know, such as the S3 bucket name, the Redshift connection ID, and then how to actually then any of the options to copy that into the warehouse. Now, one of the things here is that this expects a connection ID, which we don't currently have in Apache Airflow. So we need to create that. So again, we go to connections, we can see here there's a whole bunch of connections that are already here, but there's no Redshift default, I don't think. No, there isn't. So we're going to create one. So what we do is we create a new record, and we're going to create this Redshift default. A lot of these parameters are already here. So I'm just going to quickly go through here and specify these. Let's make sure this is now. For things like passwords, these are encrypted in the database. So you don't have to worry about them because once we save this, it'll be encrypted and not accessible. So we've now created our connection ID, which means that now this workflow will know how to connect with Amazon Redshift. So we've got this already, and now all we need to do is copy this into our workflow folder. Okay, and I'm hoping, because this is live, I'm hoping the demo gods are going to be kind with me. And yes, we've seen it, and it's here, right? So if I open this and I go to Graph View, we can see that this actually now looks a bit more of an interesting workflow. We've got all these different tasks. Some of the tasks split off to separate tasks. So once the files are copied, there's 3 files that are copied. We want to there's a movie table, a ratings table, and a tags table. And then we want to merge those all together. And then we run the cleanup script, and then we transfer it. So let's actually now enable this. And actually, whoops. And let's enable this and actually now run it. Now, it should actually fail. So I don't want people to worry that it's failing. But it should fail, and we'll explain why in a second. But what's going to happen now is it's going to start to download the files from S3. So it's downloaded them. It's gone from light green to dark green. It's now copying the files to the S3 bucket, different S3 buckets, and it's then going to kick off the different tasks, the different Athena tasks. Now, what's going to happen is these will kick off. You can see they're green. But the Athena tasks should fail. They should fail because I haven't created the Athena database yet. Okay, so what we should see is them going red. Now, why I wanted to fail this is I wanted to show you how you recover from a failure. Because if you think about it, when you've got complex workflows, when there's an error, you don't want to fail and then have to redo the whole workflow again. What you want to do is just carry on from where you failed. So what we're going to show you is how we do that in Apache Airflow. So there we go. We can actually see the error by going into the log. And we can see here somewhere that there is no database does not exist. So I'm going to go into Athena, create the database. And hopefully that's completed. And now if we go back to the demo, go back. What I can do is I can open the task, I can click on clear, and I can click on OK. And what it's going to do is it's going to clear the task and retry it just from that step. And I'm going to do it for the other 2 as well, so that they run as well. And do this one. Oops. Nope. No, I don't want that. I want clear. Clear and OK. Good. And now they're now running. OK. So this is going to take a few seconds, but we can see the first one is already finished. And what will happen is Apache Airflow, because all these tasks are parallelized, this task will not start until all of these have been successful. So we'll see once this last task has gone dark green, it will start the next step of the process. Now, whilst we're waiting for that, we can actually see the code, just to show you that this is the same code. We can actually look into this. You can see this is exactly the same code that we had in Visual Studio. So let's go back, because I think it was actually kicking off. So you can see now that those 3 tasks have finished. It's now running the join Athena tables, which should run very quickly. And then the final task, once it's done that, is to run the Python script to remove all the letter E's from the data. So, and also what we can do is we can actually look at what the logs look like in the Athena tasks. We can see when it's running, we can see that actually it's running the query, running, and then it's exceeded. So we can see that different operators will produce different outputs in the logs. Now, I mentioned that, so actually it's actually now finished. But before I kind of show you what the data looks like in Redshift, I mentioned about how we get data between tasks. And what we can see here is there is a feature within Apache Airflow called XCOM. And XCOM allows you to push and pull state between tasks. Now, in these different tasks, these Athena tasks, I need to know the query ID from one task to the other. So what I've done is I've actually pushed it, and then this one is pulling it. So I know the query ID from the previous task, and that allows me then to know how to process this. So this is how an example of how Apache Airflow manages state. So I wanted to do that before going to showing you actually now what it looks like. We go to Redshift. We can go to our warehouse, and we'll run a query, and the query will basically list the top movies. I run this. Hopefully it will work. And we can see that it's returned our query. Now, if our data pipeline has been successful, we should have no films with the letter E. So if we go down, we can see that it looks like it's worked, because this should be Grumpier Old Men, Father of the Bride Part 2, Hate, Sabrina, Golden Eye. You can see that our workflow has worked. And we can actually go in into S3, and we can actually look at all the data if we wanted to here as well. So that's a very kind of quick demo of a real one in action. And actually, I've been running everything locally on my laptop, and you can, if you want to, also run exactly the same workflow on a managed service of Apache Airflow. So AWS has a managed workflow, a managed service for Apache Airflow called Managed Workflows for Apache Airflow, or MOA. But there are others as well. We have Astronomer also have their own offering as well called Astro. So you've got choice. You can either run it yourself, you can use a managed service like MOA, or something like Astro. So let's now go back to the presentation and finish before we can wrap up with some questions. So that was the demo. Okay, so I've showed you a little bit about Apache Airflow, some of the concepts behind it, some of the terminology and the architecture, and then walked you through a demo. But Apache Airflow is not static. It's an open source project. It is continuously being improved. New features are being added on a regular basis. And these are just some of the recent updates. One of the things that's, I think, most exciting is how, as a project, they're looking to make it easier to create cleaner, more Python native code when you define your workflow. So this is not a static project, and I encourage people who are interested in Apache Airflow to take the learnings from this session and explore Apache Airflow, yourselves. The project itself, the community, Apache Airflow community, is a very welcoming community. I blogged about this earlier this year. And so if you are a developer and you're looking to find a project that you want to learn or contribute to, then I can highly recommend the Apache Airflow community. They spend a lot of time welcoming and helping new contributors. And those contributions could be along any other spectrums. It could be documentation, examples, as well as kind of code contributions. So I highly encourage you, if you're looking for a project, to reach out to the Apache Airflow community. They've got a very active Slack community, very welcoming, and they're a great place to start your open source journey. So all the code for this presentation is available on that. And if you want to find more information about Apache Airflow, the project, then go to airflow.apache.org. It's a great site, lots of really good information there, from basic installation, lots of details about how the operators work, and tutorials. And with that, I finished the presentation. Just to wrap up, I do a lot of other open source work at AWS. Here are some of the ways you can keep in touch with that. And with that, thank you very much for your time. You can contact me via Twitter or Mastodon or LinkedIn. And if you want a copy of the presentation today, which contains all the links, then if you click on that QR link, that will allow you to get a copy of the presentation after completing a very short survey of 3 or 4 questions. And so with that, I have finished my presentation, and I would love to take on any questions that people have got.
Thank you, Ricardo. We do have a few questions, and we have about 4 minutes to answer as many as possible. So let's get to it.
Okay.
The first question from Claudio is, what would be a best practice to pass data between tasks?
To pass DAGs between tasks. I don't think I could answer that one in the time. So I think, Claudio, if you want to contact me in the lobby. I'll be in this event environment. So why don't you reach out to me and we can have a more in detailed discussion around that.
That's an offer for a long form answer, so that's good. David asks, how would you build test into an Airflow pipeline?
Oh, great question. So I didn't cover that deliberately in this introduction session. I am in the process of writing actually how to do tests and how to do CI/CD with Apache Airflow. But the short answer is you can do it, and you do it at lots of different levels. So you do it. The way I like to do it is, again, taking the shift left approach. Within your developer setup, I run locally this project, Moi local runner. And I have configured pre-commit hooks that run a bunch of different test scripts. So I do sanity checking on my Python files. There's a number of different open source projects that allow you to do DAG checking. So stylistic checking, as well as whether the DAG is well formed. You can do things around whether the imports within Apache Airflow are going to break Apache Airflow. So you can use constraints file. So the idea is you run all these checks locally before you commit to your DAGs folder, and you reduce the amount of errors likely when you actually roll out that to your environment. Okay, so there is a way of doing it. Again, I encourage you to watch out for my blog posts. I do a number of blog posts on Apache Airflow. I'm in the process of writing one specifically around testing. I do also have a colleague, Gary Stafford, who's already written a really excellent blog post on some of the ways that you can do testing within Apache Airflow. And he's tiered it. So kind of basic, kind of single developer, kind of group developer, and then kind of enterprise type level developers. So again, Gary Stafford, if you Google him and Apache Airflow testing, you should get his blog post on that.
Great, thank you. We will attempt to answer a couple of questions here. Firstly, Claudio asks again, is there a GCP Composer equivalent in AWS?
Is there a GCP Composer what? Sorry?
Equivalent in AWS.
Right, so Moi local. So Moi is called Amazon Managed Workflows for Apache Airflow. Is our managed service. It's the equivalent to Composer. So we do have a managed service, correct?
Great. Arthur asks, is there a way for a task in one DAG to be dependent on a task in another DAG?
So you can build relationships with tasks between DAGs. That's beyond the scope of the basic session I did today. But there are a number of different ways of doing it, including new capabilities with newer versions of Apache Airflow. So that in newer versions of Apache Airflow, you've got the Triggerer API that allows you to do this. The way I like to do it is by effectively either using event-based approaches like AWS Lambda to trigger a workflow after another workflow is finished. So the kind of short answer is there are lots of different ways you can approach this. It very much depends on your particular use case and circumstance. But again, that's more a kind of, I guess, an advanced use case not what I was really hoping to cover here. This is very much a kind of entry level introduction into Apache Airflow. But again, if you want to know more, I'm happy to talk to you about these more detailed questions as part of offline conversation.
Great, Ricardo. We do actually have more questions, but we are out of time, and we will attempt to get all the questions answered with the help from the conference organizers, but also do reach out to Claudio if you would like some personalized answers. And he's just told us he has a great blog where you can get all this in long form. So please do go and check that out. Ricardo, thank you so much for sharing your knowledge with us today. Really interesting and engaging and very detailed at the same time. We covered a lot in 45 minutes.
Thank you.
We will finish here, and we will be on with the next session very shortly. So enjoy your short break, and we will see you shortly.
Thank you, everyone, and enjoy the rest of the show.